Hey, it's Jay. Today I'll be talking about negative feedback. In the last video, I talked about homeostasis and how a process called negative feedback corrects a change from a normal set point. If that last sentence didn't make sense, click the video in the upper right to watch that video. Today I'll be talking about the details of negative feedback, and I'll use a couple of examples to illustrate the points. By the end of the video, I hope I will have hammered home the importance of negative feedback loops and staying alive. Homeostasis refers to maintaining a stable internal environment. The example I used in the last video was maintaining a steady body temperature. Human body temperature is about 37 degrees Celsius. If our body temperature rises from that set point, we have to cool off. And if body temperature drops, we have to warm back up. The process that reverses a change in homeostasis is called negative feedback because the response is opposite from the initial change. For a negative feedback loop to work, we need three components. We need a sensor, a control center, and an effector. I'll get back to body temperature in a second, but to introduce these components, I'll use the analogy of a thermostat turning on an air conditioner to maintain a room temperature of 25 degrees in the summer. The sensor in this case is a thermometer, which changes shape as temperature changes. The control center is a mechanism in the thermostat that reads the thermometer and interprets the change as it gets above the set point. At that point, the control center sends a signal to the air conditioner, which turns on and reverses the increase in temperature. If anything in that loop is broken, we can't cool the room in the summer, so hopefully neither your thermostat or air conditioner break on the hottest day of summer. Now let's fill in the loop that cools our body when we get too hot. We need a sensor that changes shape as body temperature gets too high. Those are thermoreceptors that are located in the skin, inside our body at various places, including an area of the brain called the hypothalamus. The control center in this feedback loop is the hypothalamus. It can detect the change in thermoreceptors and send signals through the nervous system that turn on sweat glands and increase blood flow to the skin. So the effector tissue includes sweat glands, the heart, and blood vessels. If anything in that loop is damaged, we won't be able to cool our bodies, and that happens in heat stroke. If the hypothalamus is damaged because it gets too hot, it can't turn on the sweat glands or change blood flow to the skin, so we get in trouble really fast. Notice that I use a tissue for the effector. I said sweat gland, but I didn't say sweating. As a counterexample to heat stroke, imagine sweating in a humid environment. The sweat glands work fine, but the sweat doesn't cool us because sweat has to evaporate to cool us, and water doesn't evaporate well in a humid environment. If we look at heat stroke, this is a disease because there's something wrong with our bodies. If we're in a humid environment, there's an issue with the environment, but not our bodies. Let's look at a second example to show how we're always following this general theme. Our bodies have to maintain steady levels of blood oxygen and CO2. I'll look at CO2. If CO2 levels rise, there are sensors that change shape, and that's interpreted in the brain. When the brain recognizes a rise in CO2, it will tell the heart to pump more blood vessels to send the blood to the right places, and stimulate muscles that cause us to breathe. The increased blood flow and respiration gets rid of the CO2, and we return to the normal set point. Moving on to a quick summary. Humans have to maintain homeostasis to stay alive, and in order to do that, we depend on negative feedback to reverse any change from a set point. A negative feedback loop has three components. It has a sensor, a control center, and an effector. The sensor changes shape when a variable changes. The control center interprets the change in shape and sends a signal to an effector, which is a tissue that, when it functions correctly, can reverse the change. Anytime we see a disease that's a disruption in homeostasis, we can trace the problem to a defect somewhere in this negative feedback loop. And we'll look at this in more detail as we go through different physiologic systems.